In this video, I will go over the concept of curl. I'm showing you here the definition of the del operator, and I have a vector function f sub x, that's the x component, the y component, the z component, and I'm multiplying these components with their corresponding unit vectors. Now, the definition of the curl is that it is a cross product. Okay. The curl is defined as the cross product between the del operator and your vector function f. Now, we know from cross products, we know that we can calculate them as the determinant of the following matrix. So the first row, a review from vectors, the cross product of two vectors. For the first row, I have my unit vectors x hat, y hat, and z hat. And then the second row is occupied by the three components of the first vector, in this case the del operator, and the three components are the partial with respect to x, the partial with respect to y, the partial with respect to z. And the third row is occupied by the three components of my function, of the second vector. In this case, it's my function. So this will be f, the x component of the function, the y component, and the z component. Now, we know that we can calculate the determinant of this, and this will give us essentially the three components, the x, y, and z components. I'm gonna start, I will start writing these. I will probably run out of space over there. So let's go here. The curl is the x component times, I'm crossing out these two, so I end up having the partial of f of z with respect to y minus the partial of f of y with respect to z, followed by minus y hat. So I'm crossing out this column and this row, and that gives me the partial of f of z with respect to x minus the partial of f sub x with respect to z. And then I have plus z hat. I'm crossing out this column and that row, and here I have the partial of f sub z, the z component of the function, with respect to y minus the partial of the y component of the vector function with respect to z. If you don't remember, if you're not comfortable finding the determinants and you need to work with curls, it will be a good idea to review how you can find the determinant in this case and find the curl. Now, it is so the curl, as we expect, okay, it has to be a vector. It's the cross product between two vectors. It has to be a vector. So every time you're calculating the curl, you need to be finding your final result needs to be a vector. Now, it is very difficult to show you the interpretation of this in 3 dimensions, but I can show you the interpretation of this if I just use, say, so I'm gonna say this is the x, and this is the y, and I'm gonna choose, so let's say this is the x, this is the y, and I'm gonna start, I will start drawing an example for a function. of course, my straight lines are not really that straight, but you get the idea. And okay, and the same thing, you can imagine something even bigger. All right, I'm gonna stop here. So I'm gonna look into this last term, the z component of the curl of this particular example. I'm gonna focus on the two terms, the two partial derivatives. Now I made, okay, so this cannot be true. I made a mistake. This needs to be, all right, so let me fix, I need to fix, all right, so there is no partial with respect to z, and this would not be, okay, all right, so let's see. For my z component, I will have the partial of f of y with respect to x, and then it will be the partial of the x component, and that will be with respect to y. All right, so I got that mistake. Now, so what I will work on showing you is the interpretation of this last term, and what that means. I'm gonna work first on seeing what's the meaning of this. And as I have told you in my previous videos, the way to interpret this partial derivative, you have to think about making a change in x, and then when you make a small change in x, then you have to evaluate how, if at all, the y component of the function changes. The change of the f of the y component of the function. Let's see. So let's do that. As I go, so I need to make a small change in x. All right, let's say I start from here. I am on the x axis just to make my life easier. I start from here and I go there. This is my change in x. It's a positive number. I'm going from a small x to a larger x. And I need to think about the change of the y component of my function. Look at these three vectors. Their projection to the y-axis, or the y component, okay, this arrow here ends up having a greater y component, and this one has an even greater y component. So when I make this small change in x, the y component of the function has a positive change, and this brings me to concluding that this is a positive number. Now, the other term is the partial of the x component of the function with respect to y. What does that mean? I need to make a change in y, and then I need to evaluate how the x component of the function changes, if at all. Let's do that. So I'm gonna start here. That's my initial. Then I'm gonna go up. Say that's my final. Okay, this is my change in the y. Now I'm gonna use these three arrows, and by the way, you cannot see, I did, this one is a little bit longer than that, but it's extending here and does not show up because I wrote with the red. So when I make that small change in the y, I go from here upwards, I have a positive change in y. I need to see how the x component of the vector function changes. Okay, Now here you can see this short arrow is pointing to the left, which means I have a negative x component of the function, say -1. This one arrow though is longer, so let's say the x component of my function is -2, and then here I end up having -3. So the fact that I go from -1, -2, -3 is telling me that for a positive delta y, I end up having a negative change in the x component of the function. That means that this partial derivative is a negative number. Now I'm gonna use this and this over here in this last term. So I found that this one is a positive number, this is a negative number. Now pay attention, I have a minus sign. A positive minus a negative number should give me also a positive number here. If you take everything together, the whole thing, the z component should be a positive number. So my curl in this case will have a positive z component. It's gonna point in the positive z direction. If you take a look at the big picture here of my vector field, you can see that my vector field is actually curling around. And if you have your the fingers of your right hand curling in this direction, your thumb will point in the positive z direction. Okay, this is the interpretation of the geometrical interpretation of the curl. However, just keep in mind, I did constrain myself to work with x and y, and I only looked at the z component of the curl. But the important thing with the process that I showed you, making the small change in x and looking at this and the same thing here, if you want to look at what's the interpretation of the first two terms, the x component, the y component, you can do it. And I showed you one example here. So this is how the curl is defined, this is how you can calculate it, and this is what the interpretation of the curl is.